Q-tips, and be careful with Q-tips and stuff, by the way. I know that feels good, but be really careful. In babies, we have specialized Q-tips. Have you seen them? What do they look like? They're like really big and round and then just have a little tiny nub at the end so that you can't puncture all the way into the middle ear and damage the tympanic membrane. This drum is very, very important to allow the transduction of those vibrational sound waves and get them to the bones and then get those fluid vibrations through the actual cochlea. Now in this diagram, what we do, all these, it makes it easier to see when you stretch out the cochlea so you can see what happens. Because otherwise it's all spiraled up and tight and hard to see. So, all the structures. Stapes, oval window is right behind it, where it kind of compresses. So these sound waves actually traverse and they go through. And depending on their pitch equals frequency, right? If you do a high pitch, that's a high frequency. If you do low pitch, that's a low frequency. The sound waves are spread out more. High pitch, they're closer together. So depending on where that pitch is, it will kind of go through and then those sound waves will dissipate and go out ultimately of the round window. So kind of leaving the cochlea itself. But the point is they go through and they activate that set of hair cells that's at that location along the cochlea. This is something that's pretty amazing. The cochlea is an amazing organ, just like your brain. It's just amazing how everything lines up, and the eyeball. We call this a tonotopic, I have this in your study guide, map. Your book goes into this